We've now proceeded through the problem definition phase of our design process. So we have a top-level description of the problem we're trying to solve and a nice list of user needs. We now proceed from what is fundamentally a problem of defining the what into the challenge of the how. This is the actual design part of our process. What are the various solutions that might address the gap in the user experience? The exploration phase of our design process is going to result in a set of design concepts. What do we mean by a concept? Well, a concept is usually a visual description of a solution that we think might address the gap in the user experience. It's often a sketch, and particularly in the case of a physical product or a physical artifact, it's a sketch of the physical embodiment of the solution that we're envisioning that could address the gap. For example, here are 10 concepts that were generated by 2 of my students in my product design class at the University of Pennsylvania. These are concepts for a problem they were addressing called the underwallet. How is it that particularly females can carry an ID card, a few bills, and a key unobtrusively underneath their clothing? That was the basic problem they were addressing. And they did a nice job here, shown in these sketches, of articulating 10 solution concepts. That's really where we're going here. We're trying to figure out a way or a method to generate some alternative solutions. And the end result of the exploration phase you can think of as a set of 10 concepts represented by sketches. I want to spend a few minutes talking about the importance of the concept. Why is it we care about a good design concept? There are 4 main reasons, and I want to just take them in turn and use some examples to illustrate those main reasons. First, the first and foremost reason that we want a great design concept is to address the user needs. And let me just give you an example. This is the Kind, or Kind, I'm not sure how you pronounce this brand, snack bar. The concept is a nut and seed-based bar with very little binder, very little sugar, that's displayed in a transparent package that emphasizes the freshness of the bar and the natural qualities of the bar. If you look at how the bar is described on the package, it's all natural, it's gluten-free, it has no sugar alcohols, it's low glycemic, very low sodium, and dairy-free. Those are all benefits that are responsive to the user needs of the target customers or target users for the makers of this bar. So first and foremost, a great concept is responsive to the user needs. Second, a great concept is responsive to the challenges of cost. For physical artifacts, it's almost always the case that the producer or the supplier of the artifact cares deeply about value creation, and that is how much more is the artifact worth to the user than it costs to manufacture or provide it. And so cost is an extremely important objective in design. Let me give you an example of a concept that's very responsive to cost. Many of you have probably know about Glide dental floss. It's a nice floss. It was pioneered by the company W.L. Gore, and it's made from Teflon, or polytetrafluoroethylene, which is the compound. That's a compound that's very slippery, and Glide is particularly useful or valuable to customers who have, or users who have, very tight gaps between their teeth, thus the name Glide. Now, the Glide itself is an interesting product, an interesting artifact, but it's the package that I want to talk about for a minute. It's a particularly clever design. Here's the original Glide floss package, and it has what's called a living hinge, which is a molded in plastic hinge, and then the package itself is hinged so that the entire package, or most of the package here, is a single injection molded part that has been designed in a way that it can come out of the mold relatively easily and can fold up in order to form the product package. My guess is that the manufacturing cost of this package is just a few pennies, a few cents, pennies on a US dollar, and so very, very inexpensive. And this is an example of a design concept for a package, for a product that is primarily about cost, about low manufacturing cost. The third motive for a great concept is what I call the wow factor, and I want to give you an example of that. This is the measuring cup produced and sold by the housewares company OXO. OXO is primarily known for its ergonomic grips and housewares that are easy to use, kitchen utensils that are easy to use. Measuring cups have not changed much in probably 100 years, but OXO has a nice innovation here, which is that if you'll notice here, there's a beveled edge here, essentially a shelf on the inside of the cup. It's angled at 45 degrees, and it has the units of measure printed on that shelf. And what that means is that you can, let's say you needed to pour 500 cc's of oil, you'd pour it like this, and you could look down at the shelf from the top without having to hold it like this in order to read the measure. So measuring cups are a relatively low involvement artifact for most people, but this shelf feature, which addresses a gap in the user experience about how difficult it is to hold and measure at the same time, is a clever element of the design, which gives what I'll call some wow factor. Now, the wow factor is valuable for at least two reasons. First, in a commercial context, if you have some wow, then you typically also can achieve some intellectual property protection, usually in the form of a patent, which provides some barrier to competitors replicating your design. But the other reason, maybe even the more important reason, is that if you've got some wow in your design, then it gives you something to talk about. It can get the user excited about the product. It can attract the user's attention, and in a commercial setting, it allows for this product to distinguish itself from the other competing alternatives that the user is faced with when making a purchase decision. So wow is usually an important attribute, but still secondary typically to meeting the needs and to having low cost. The fourth and final motivation for a great concept is aesthetics and elegance. And that is, as designers, we should strive to create things that are beautiful and that are elegant. And I'm going to give you here an example. This is the example of the Zuder logo. This is the logo for a company that I created about 12 years ago. This logo, I think, is quite beautiful. It was created by the designers Becky Brown and Flo Bautista at Lunar Design, and they carefully crafted the logo type, XOOTR, the two O's. Zuder is a scooter company, and the two O's are suggestive of wheels. The connection of the letters is suggestive of a fluid flow, and then the outline, that oval outline, was suggestive. They thought it evoked the notion of a surfboard or a skateboard, a kind of an action sport metaphor, which they'd hoped to invoke as part of the brand. The logo itself is quite elegant, quite beautiful, and aesthetically attractive. And that should be an objective of all of us as designers, to create things that are beautiful. And the beauty or elegance, the aesthetic appeal of an artifact usually begins with the concept. Okay, so those are our objectives. We want to create something that meets the needs, can be produced at low cost, has some wow, and is beautiful. How is it we do that? Well, fundamentally, we're going to take a very simple approach, which is we're going to generate a lot of alternatives a dozen, 2 dozen, maybe even 100 different solution concepts. And then we're going to carefully select from among those in order to find the exceptional concept, the concept that's going to eventually prevail and be a great solution to our design problem. Before we get into the mechanics of how it is that we're going to generate those dozens or hundreds of solution concepts, I want to emphasize three points, just at a general level. The first point I want to emphasize is concept generation, exploration is really hard, and it takes much more effort than most people appreciate. I'm going to give you a tiny little example just to illustrate what I mean. I showed you this design concept. Some of you might have noticed this little stick figure in this concept. And this is an illustration that I designed for the book that's associated with these modules and that's associated with the course. And one little element, the stick figure of one little illustration of dozens or hundreds in that book, was the result of deliberate exploration. Indeed, I went back through my files and I found this sheet, which has on it about 100 different alternatives for what that stick figure might look like. And I eventually found one that I thought worked quite well, that I thought met the needs, that I thought was elegant, and that I did. Maybe wow is an overstatement for a stick figure. But the main point I want to make here is the tiniest design challenge, if done well, is still requires tremendous effort. This is hard work. You need to be prepared to do hard work to get great outcomes. The second point I want to make about exploration is that we'd like to believe that great design concepts are the result of some combination of our brilliance, hard work, and great process. But the reality is we need to be open to ideas that come from anywhere and everywhere, and that in fact sometimes it's dumb luck that leads to a great design concept. Let me just tell you a little story about that. I'm the inventor of a bicycle seat called the Nexride bicycle seat, and I want to tell you where the concept came from. I'd done a lot of work on bicycle seats. I'd followed the methods that I'm going to teach you in a little while, and I'd done some experimentation. But one day I was out riding my bike recreationally, and I was riding one of the saddles that's essentially a bench-shaped form, a rigid bench-shaped form. I was out riding my bike one day, one summer, and the seat post clamp, that is the clamp that holds the post and holds the seat rigid, broke. And I was stuck out maybe 20 kilometers from home with a seat post that was free to move in the frame. And I had no choice but just to ride the bike home. But strangely, as I was riding the bike home and as the seat post was free to move, I noticed that this bench seat was able to pivot, and that pivoting action made it much more comfortable. And so I immediately went home and I created some prototypes, and I eventually ended up inventing the Nexride bicycle seat, which has as its integral to it the notion of a pivot. That pivoting concept came from a dumb accident, a broken bolt out on a bike ride. I'm not complaining. I'm just saying that you need to be open to the possibility, to ideas from any source, including dumb accidents. Lastly, I want to point out that even though we have a design process and we're going to have some methods for doing exploration, I want you to understand that concept generation, exploration, design generally is highly iterative. It's quite likely that as you generate the design concepts, the definition of your problem will come into focus, will become more clear. It's also quite possible that as you proceed to refine a particular concept, build prototypes and test, you'll have additional ideas for new concepts. That's normal. Don't be alarmed. That is fundamental to the way design happens in practice. There's iteration required in order to achieve great outcomes.